Hello everyone, my name is Mátyás Török. I'm the head of the Department of Industrial Materials Technology at Bajk Zoltán Nonprofit Ltd. for Applied Research. Our company is the leading institute in Hungary for applied research. We have 27 years of experience, more than 200 industrial partners, and approximately 130 highly educated researchers. Our aim is to create partnerships all across Europe. This is why so far we have participated in approximately 160 successful projects. One of them is RADIUS, recycled automotive brake discs by upgrading metallic scraps. The aim of the project was to produce a cast brake disc from recycled aluminium alloy. If we reduce the weight of the vehicles by exchanging steel parts with aluminium, the overall energy need of said vehicle will drop too, which is desirable for a sustainable future. The main problem with aluminium and its alloys is that they are too soft and frail to be used as a long-term brake. They wouldn't endure the increased stress. The solution for this problem can be to develop a hard, wear-resistant coating on the metal base. We tried 4 different methods on the test samples: laser surface alloying, sol gel method, plasma electrolytic oxidation, and anodizing. Before we start the coating of the samples, we have to degrease them so the surface treatments can be effective. During the laser surface alloying method, we used a CO2 gas laser with a 5-axis CNC. The aim of this method was to melt together the prepared hard metal alloy powders with the base metal. The sol gel method used aluminium isopropyl oxide as a precursor to form an oxide layer. The plasma electrolytic oxidation used high voltage to treat the surface of the samples. The anodizing method is a low voltage electrolytic treatment in which we use a relatively less hazardous chemical as the electrolyte. The best results were delivered by the anodizing method, so we continued to further develop this coating technology. We tested several parameters regarding temperature, current density, and the concentration of the electrolyte. The results were evaluated by various measurements, such as the roughness of the samples, the phase composition of the coating, the hardness, and the wear resistance. Finally, we got the desired results for the test samples. The next step in our work was to upscale the coating technology and work on real brake discs. We created an anodizing equipment for this special task. The disc goes on a rod with which it is immersed in the electrolyte. The end of the rod is attached to a rotating motor. The rotation of the disc is necessary so we can get an even coating. The control electrodes are placed in the tank. Then the high current power supply is turned on. The anodizing goes on for a specific time, then the brake is removed and thoroughly rinsed. The success of our technology was evaluated with the same measurements as mentioned before. The coating process comes with only one byproduct, the metal-containing electrolyte. As it is a hazardous waste, normally it would be collected and sent to special treatment plants to be neutralized. However, it is not the most eco-friendly way, and the European Union propagates the zero-waste approach as well. This is why, after the successful upscaling of the coating technology, we aimed to develop an easy but reliable way to reutilize the electrolyte. The electrolyte is mixed with a solution of transition metal salts, typically copper and cobalt compounds. After mixing, precipitation occurs, and depending on the composition of the solutions, the color of the precipitate will rise. After filtration, the solid material can be recovered and used as a pigment. This is how our work and role in the RADIUS project looks like. I hope you enjoyed the video and thank you for your attention. I would also like to thank the contribution from our partners. I am Mátyás Török from Bajk Zoltán Nonprofit Ltd. And don't forget, Live greener, think greener.